Hello.
Hey, everybody. How's everybody doing?
How about you?
Professor, where can we find the Dropbox?
I sent you a link at one point, but I can send it again. If everybody could mute yourself, I'm getting some background noise, unless you need to ask a question.
I have a question. I don't know if I missed it or not. I just joined. Were there notes for the midterm grades or just a grade?
One more time.
Like, did you leave any notes for the midterms or just a grade?
No, I sure did. I left comments all over them. Yeah.
Okay, I take a look at that. Thank you.
So, as long as you're, sorry, so the first question was, how do you get Dropbox? Is that right? I sent you a link. I'm happy to send it again. And then as far as the midterms, hold on a second. As long as you're asking, the midterms, I've graded most of them, and I have about 20 left to grade. So you should start seeing those. Those should turn up in Blackboard around 4 o'clock. I think you'll start seeing them. And I graded them in the order that I received them. So if you turn it in early, or you probably are going to see your grade today. If you turn it in toward the end of the deadline, maybe not. So, but I'm almost done grading them. Let's see. So today we're going to talk about the Brooklyn Bridge. And you have your reading report, forget which number it is, but the Brooklyn Bridge reading report. The first of 2 on the same reading is due today. It's either reading report 5 or 6, I can't remember, but it's on chapter 1 of David McCullough's The Great Bridge. And so the first reading report is about chapter 1, and the second one is about chapter 9. So you're just reading 2 chapters in here. If you want to read the whole thing, I encourage you to do that. It's a really interesting book and kind of reads like a novel. He's a really good writer. So the one that's due today is on chapter 1 called The Plan. And then the next reading report is on chapter 9. Okay, looks like Ashley has shared the Dropbox with everybody. Thanks, Ashley. Anybody else have any questions before we get started?
I don't see the comments on my midterm either.
I haven't turned back what are you seeing when you?
I see my grade, but I
You
don't
do?
see any comments. Yeah.
That's weird. If you click on the exam, you don't see anything?
No.
Yeah, same
Yeah,
for me.
same with me as well.
Yeah, me too.
I have the same problem.
All right, well, it must be something with the settings. So I'll look into that and then maybe check back later this afternoon to see if they appear. That's really weird.
Okay, thanks.
I can't explain that. That's
Actually, Blackboard isn't working for me. It says that it's going to be restored on Sunday at 12 p.m.
Is that true of anybody else?
Yes, it's true.
Good old Blackboard taking advantage of spring break, I guess.
Yeah.
I'm sorry about that.
Can I send the report through email to you instead of Blackboard?
Let me check out Blackboard and I'll be in touch with you guys about that. Yeah, I really don't want you to all send an email to me. So, because then I'll just lose them.
Okay.
There's 85 people in the class. I mean,
Yeah, I understand.
so, they're gonna get mixed up with all the junk mail I get from City College every day, and I don't like. So before you do that, let me check it out and I'll communicate with you, and either I'll have some intel on Blackboard or I'll extend the deadline. I'd prefer to do that rather than get a bunch of reports in my email.
Okay, thank you.
You're welcome. Okay, assuming everybody can see that okay? Thumbs up there?
Yes.
Oh, awesome. Okay.
Yeah.
So what we're going to do today is we've been really concentrating on Manhattan, going all the way back to Lenape days. And what we're going to start doing is look a little bit at Brooklyn over the next few weeks. And so, of course, the way to get to Brooklyn is over the Brooklyn Bridge. So we're going from Manhattan to Brooklyn over the bridge. And then once we get to Brooklyn in the next few weeks, we'll take a time machine backwards in time, back to the colonial period, and kind of reboot our chronology and talk about Brooklyn. But today I wanted to talk about the Brooklyn Bridge as a key part of the city's infrastructure. We've talked about Central Park is a part of the infrastructure, the Commissioner's Plan, the Croton Aqueduct, and the Brooklyn Bridge is also a key part of that because it had a drastic effect on the city's built environment, as you will see when we start talking about Brooklyn neighborhoods. So this is today. So yeah, it's reading report 5 is due today. Again, that's just chapter 1. And then today I'm going to meet with group 1 at 1:30, group 2 at 2 o'clock. And I sent you guys an email just reminding you who's in group 1 and 2. If you have any questions about that, of course, let me know. And then next week we don't meet because it's spring break, of course. And then if everybody could mute yourself so I don't get background noise, that would be great. Thanks. And then when we come back from spring break, we're going to look more into the history of Brooklyn. And then you have your reading report 6 due, which is chapter 9 of the Great Bridge. And then we'll start reading Bricks and Brownstone, which is a book about housing. Let's talk about the bridge a little bit. So its construction was from 1869 to 1883. So it begins construction at that point, 1869, Central Park was still very much under construction. That's 4 years after the Civil War ends. And then it finishes in 1883. And its style is the Gothic Revival. And we're going to talk more about the Gothic Revival when we talk about housing. And then here's just showing you where it is. This should be kind of obvious to everybody, but it's going from Manhattan to Brooklyn back and forth and over the East River, which you can see there. And then this piece of land here, you'll remember from all the maps we looked at, that was originally the Commons and is today's City Hall Park. And it connects along Broadway down to the oldest part of the city. So the Costello plan from 1660 that we've looked at so much was just like down in this part of the city down here. So the Brooklyn Bridge lands on City Hall Park. So it was right in the thick of the action of the developing city, in other words. And then it extended over to Brooklyn Heights, and we'll look at Brooklyn Heights in some detail later on. And of course, when it was built, of course, there was not the Manhattan Bridge or the Williamsburg Bridge or any other bridge across the East River. This was a incredible innovation that was built because it was the only way to get across the river at that point. And you can imagine that once there was a way across the river, the development in Brooklyn really increased. So what type of bridge is it? Well, it's a kind of a unique type of bridge, which is, it's a hybrid. It's a cable stayed plus a suspension bridge. So two types of bridges. And there are stays and there's suspenders. And these are the suspenders, which are the vertical cables going up and down. And then these are the stays, which are the diagonal. So the Brooklyn Bridge has both, which means that it's extra strong. And it's always featured in disaster movies like I Am Legend, it's blown up. There's a couple movies where a meteor hits the city and it's destroyed, but in reality, it would be pretty difficult to destroy the bridge because it's so strong. Hold on a second. It looks like the controls are on automatic here. Okay. So it has stays and suspenders, and then it has these great four arches as the main structure. And the roadway is suspended from these four cables that are going across. There's two here, there's one there. So one on either side, two in the middle, going over the top, threaded through the top of the two towers, one on the Brooklyn side, one on the Manhattan side. And the reading goes into a lot of detail about how the towers were constructed, which we'll talk about a little bit today. One of the towers on the Brooklyn side, they managed to take it all the way down to its proper depth and create a foundation. On the Manhattan side, they weren't able to do that. I think that's described in chapter 9, because the bottom of the river was so hard packed, they couldn't break through it. So the tower on the Manhattan side is actually just sitting on the river bottom. The one on the Brooklyn side has deeper foundations. And then the roadway is suspended, that's, suspension bridge from the cable. So they have these really elegant parabolas. So it contributes to how beautiful the bridge is. And then this is a section through one of the big cables, and you can see that they're actually bundles of 19 coils of steel wire. So that's what a section looks like through the cables. So it was the world's first steel wire suspension bridge. And it was the longest suspension bridge in the world until 1903. And the materials are granite and limestone for the towers, and then steel for the wire. And so we're talking about building materials in this course. We've talked about schist as a building material. We've talked about marble. We've talked about brownstone. So we talked about a lot of heavy kind of masonry materials. We haven't talked about steel yet. So this is the first time we talk about steel. And we're going to see that more when we talk about skyscrapers. So the engineer of the bridge is a really interesting, important character, John A. Roebling. And the first chapter kind of introduces him as a character. And in the first chapter, it begins with him presenting his drawings to this commission of consulting engineers who are going to pass judgment on his plans. And it also describes a kind of tour that the engineers take to look at his work. So he had to audition for the part, and they kind of put him through the ringer before they agreed to hire him to design the bridge. even though he was already pretty well known at that point. But this was by far the biggest suspension bridge that had ever been built. So in the first chapter, they describe kind of how wary they were of him and how much he had to go through to kind of audition for the part. So he was from Germany. He was an immigrant. And in Germany, he had studied engineering and architecture. And one of his professors, not for engineering or architecture, but for philosophy, was the great romantic German idealist philosopher Hegel. So Hegel was actually his teacher, and he had a profound effect on Roebling. I think this is described in chapter 2, which you're not reading, but if you want to read that, if you want to know more about it, you can read chapter 2, describes his whole upbringing. But Hegel remembered Roebling as his favorite student, which is pretty high praise. And it's interesting, isn't it, considering that Roebling was an engineering student, and yet Hegel, one of the greatest German philosophers ever, considered Roebling as his best student, or his favorite anyway. So he was a great engineer, but he was also a philosopher and a philosophy student, and not just any philosophy student, but a really exceptional philosophy student. It was Hegel who talked about America as a land of hope. One of many people who talked about America as a land of hope and promoted it to immigrants as a place where they could really make something of themselves. And he encouraged Roebling to go to America and try to make his name there, which of course millions of immigrants have done. So that's what he decides to do. He left his small town of Mühlhausen in Germany and immigrates to America. Roebling was a really intense guy, and you can see it in his eyes, even in this drawing, just kind of this intense gaze. He was just extremely sure of himself. Hegel was a profound influence, and Hegel was preaching this philosophy of self-realization, confidence in yourself. You can be anything you want to be. Your destiny is your own. You can be successful at whatever you do. Kind of just unfettered ambition, and also that speaking of the eyes, that it's the truth is in perception. Like Hegel talked about that things we discover in objects depends on the way that we perceive them, so that everything is subjective. It's kind of romantic idea that you understand the world based on your perception. It's very similar to the way that Olmsted and Vaux were thinking about Central Park, that its meaning is in your perception, that it kind of unfolds in these series of perspectives. So this is an important idea in philosophy as well, not just design. So Roebling was a very intense, obsessed character. And so he takes on this project that seems crazy to kind of contemplate someone doing this, but he not only immigrates to America, he brings a whole group with him in 1831, and he starts his own utopian community in rural Pennsylvania, and it's called Saxonburg. And he has this idea, as many immigrants did, that they were going to come to America where there's so much land available, and they're going to be farmers. This utopian idea that they can start this ideal rural community. And he actually pulls it off. I mean, they build houses, they're farmers, and they found this community. But gradually, it became evident, as with many of these would-be farmers, that farming is its own skill, and it's not easy. And so Roebling was an engineer. He wasn't a farmer. I mean, so gradually he kind of realized that he should be an engineer because that's his training, not a farmer. And so he moves his family to Trenton, New Jersey. So he goes to a city and he works on canals and railroads as an engineer. And he starts this company that is a factory for making wire rope. So iron rope and then later steel rope. And he's very successful at this. So he becomes a manufacturer of wire rope. And then from there, he starts building bridges for railroads, and then he starts building bigger bridges. And his most famous bridge, the thing that really put him on the map, was the Cincinnati-Covington Bridge, which was finished in 1866, so 1 year after the Civil War ends. And you can see it here. It's like a kind of a slightly, smaller, kind of clunkier version of the Brooklyn Bridge. It definitely foreshadows what he's going to design in Brooklyn. It's a suspension bridge. It's got the stays and the suspenders, just like he would build in Brooklyn. It's got the big arched masonry opening. So he builds this bridge, and it's kind of what makes him famous in engineering circles, over the Ohio River from Covington, Kentucky to Cincinnati, Ohio. And it's still there today. Today it's known as the Roebling Suspension Bridge. So this was his calling card. And then from the Covington Bridge, he's able to then design the Brooklyn Bridge. And here you can see some of his original drawings. The one on the right showing one of the towers with its pointed Gothic arches. But, as fate would have it, things happen, and Roebling designs the bridge, but he dies before construction begins. They were still in the surveying stage of the project when he dies. So a real tragedy that he never got to see the bridge built. And the way that he died was tragic and could have been easily avoided, and it probably had a lot to do with his personality. So he was down at the river edge at Fulton Ferry in Brooklyn with his son, and then another assistant was across the river, and they were trying to figure out the ideal location for the Brooklyn Tower. And so they're taking measurements, and they were screaming across the river at one another, and or probably not screaming, because I don't think you can hear across the river, but they were gesturing across the river. And Roebling's attention was on the guy across the river, and he wasn't really watching. And one of the ferries came in to the slip right where he was standing. He was actually standing on the piling around where the ferry comes in. And he thought he had enough room. But he was a really confident, arrogant guy. And so he wasn't very cautious, and he didn't get out of the way far enough. And the ferry came in, and his foot got caught and got really badly injured. And it looked like he was going to get better, but then he gets tetanus from the injury, and he dies on July 2nd, 1869. So his son, Washington Roebling, had already been involved in the design and construction of the bridge. He had been with him every step of the way. And so he takes over the project, and has to take over really suddenly when his father dies. And he had been a hero in the Civil War, which had just ended a few years before. And he had played a key part in the Battle of Gettysburg, one of the pivotal battles in the war. And so he was a bit of a war hero. Here you can see him in later life. He was trained as a civil engineer, just like his dad. So it's Washington Roebling who ends up needing to see the project through its construction. So the two towers, let's talk about those a little bit. Each one of them was 276.5 feet tall. Roebling had designed them a little bit shorter, but in the construction, they ended up being a little bit taller. So at this point, that was taller than almost everything else in the city, even though 276 feet is not very tall compared to what's there now. Certainly not like a skyscraper. Like the World Trade Center is over 1,700 feet tall. So not very tall by today's standards. At that point, the only structure that would have been taller was Trinity Church, which still was a few feet taller. I think Trinity's spire was 284 feet tall, maybe. But in a landscape where every building was 3 or 4 stories, maybe 5 stories, you can imagine that the towers really were much taller. And so below the water line, the material is limestone. Above the water line was granite. And I think I already mentioned this, that they managed to get down to bedrock on the Brooklyn side, but on the Manhattan side, they never did because they couldn't break through the bottom of the riverbed. This is on the Manhattan side. In the background, you can see the post office building with its big dome. But generally speaking, these warehouses along the river, 4 or 5 stories tall. So you can see how out of scale it was with the rest of the city. And in the 19th century, this was extremely futuristic that they would build something this tall. This is well before skyscrapers. And it's hard to imagine what this meant to people to see this. David McCullough in the reading, he compares this to the moonshot, to the Apollo program, the first time we went to the moon, like that kind of thing. I'm not sure about that. That's, I think, a bit of an exaggeration. I kind of think the moonshot of the 19th century was probably the Erie Canal or even the Croton Aqueduct. Probably not the bridge, but still, it was a pretty ambitious futuristic project. All right, let's talk about the towers. This is so fascinating. And this relates more to chapter 9 of your reading. So how do they build these towers, and how do they build them in the water? And how do they build them so they get down to far enough that they're stable and they can support the weight of the bridge? So they use something called a caisson to build the foundation. The caissons, I'll show you a drawing in a second. It's basically a giant box, like an overturned shoebox, that's built out of heavy timber and iron plating with really thick sides and really, really thick top. And the idea was that they float it into the river and then sink it to the bottom of the river. And then workers, most of them immigrants, go down into this godforsaken space that's dark and hot and doesn't really have adequate air flow. And they dig the riverbed out and remove it through the top of the caisson. And as they remove the material from the riverbed, the caisson gradually, very, very, very gradually, very slowly sinks into the soil at the bottom of the river. So it wasn't just one room that they're working in. This thing was huge. So there were 6 rooms inside the caisson, and each one of them was about the size of a tennis court. So you can imagine this thing was really gigantic. And it was wood timbers and iron plating both. And then the so-called shoe around the edge was iron because it was a cutting edge. So they wanted it to be able to cut into the bottom of the river. And then as they sink it down, then they just start building. Once they're happy with where it is, and they start building the stonework on top of it, and that becomes the foundation, and then the tower is on top of the foundation. So this is a cross section through one of the caissons, and this is the chambers down here where people are digging. And They're digging by hand generally with pickaxes and shovels. They did start doing, they experimented with controlled explosions to try to get rid of the bigger rocks. They were very cautious about this, as you might believe, that maybe an explosion down in this confined space isn't the best idea, but they found out that it works pretty well. So eventually they start detonating the bigger rocks to remove them, but most of it was hand labor. These workers would do a shift and they would go down in one of these airlocks, which you can see here, circled here, which leads to a little chamber that they can get down into. This is a cross section of one of the airlocks. It's kind of like an elevator, and it's pressurized. And then they go in one side, they wait for it to get pressurized, and then they go out the bottom to a ladder and down into the caisson. And this here you can see kind of what it was like. This is a worker either coming or going through the airlock, and it was muddy, it was dirty, it was stifling hot down there. And people would work, they would take off as much clothing as they could because it was so hot and sweaty down there. And you can see they're just kind of loading the mud onto wheelbarrows. This part here is the shoe. This is a section, but it was actually on all four sides of the caisson. And you can see it's got a sharp edge. So as they remove material, it will gradually dig deeper into the riverbed. These are the clamshell so-called scoopers, which would remove all the material. So there were two of these. They would dump the material into the shaft, and then the scooper would pick up the material, the rocks and everything, and on a boom and remove it. So a very slow, laborious process. And then they also had supply shafts here. They could send things down, tools and equipment, food and water. And you can imagine that as the caisson starts to cut into the riverbed, there's tremendous friction from the surrounding earth pushing against the caisson. So this was good and bad, and this is explained in chapter 9. It was good because it kind of created an airtight perimeter. So initially it was very muddy when it first starts sinking, but as there's more pressure from the surrounding riverbed, there's less and less water seeping in. So it actually became a drier environment the deeper that they got. So the mud was really only an issue in the beginning. But the downside was that as you went deeper into the riverbed, there's more and more pressure from the surrounding earth. So the caisson started sinking slower and slower. So it was more and more difficult to get it to sink. They also encountered a lot of boulders. It wasn't just small rocks, which they would have to break up every single one. Sometimes the boulders would be straddling the shoe, so the shoe would come down and get stuck on a boulder. Some of them were, the size of a truck, And when there was a boulder that was partly inside and partly outside the shoe, they had to break it up enough that the shoe could get past it. And they would find one boulder, break it up, haul out the debris, and then it would sink a few more inches and they would find another boulder. And so the sinking of the caissons, I can't remember exactly how long it took, but I think we're talking about years, not months. And then, so that's kind of the tower construction methods. And then they had to build anchorages on either side on the land in order to counteract the force of the cables pulling inward. So these had to be really heavy masonry structures that were strong enough to withstand that tremendous pressure from the cables. So there's anchorage on the Brooklyn side, one on the Manhattan side. These were gigantic structures. So when they built them, they had to demolish several city blocks of buildings. If you look at fire insurance map from the 1880s, or when they were building the like 1870s, when they were starting to build the anchorage, you can see they would put in the new anchorage over the existing buildings, and the anchorages were so much bigger than everything else around it that it took out dozens of buildings that were there on both sides. And this is a section through the anchorage showing how the cables are connected to anchor bars that then eventually get down to an anchor plate embedded deep in the masonry. And that was enough to counteract the pressure toward the middle. The anchorages, because they were so big, the interior spaces were monumental. So they initially used them for storage, and they were also, the walls were so thick that the temperature inside the anchorages stayed pretty steady for 12 months of the year. So they would use them to store wine and things like that that were susceptible to temperature fluctuations. There was an idea of maybe using them to store money for the US Treasury. But generally they were used as storage spaces. But they're incredible spaces, some of the most beautiful, huge, gigantic, cathedral ceilings of any space in New York. And unfortunately, they don't let you go inside the anchorages anymore. After September 11th happened, the authorities decided to restrict access. And so last time I checked, you can't go inside the anchorages anymore. When I first moved to the city 20 years ago, you still could. And so I would go to, they would have events in the anchorages, and I would go, at least on the Brooklyn side. And they were just incredible, huge, huge spaces. I don't know what this is. This is some kind of art performance. It looks like, I don't know, I'm gonna guess 1970s maybe. People suspended from the ceiling on tables and chairs. I don't know what it was, some kind of performance art, but they did things like that in the anchorages. So the original Roebling was killed by a approaching ferry, and then his son, Washington Roebling, is incapacitated by something called caisson disease, which was very mysterious to them. So I showed you the airlocks where the workers are going down into the caissons. As they got deeper and deeper into the riverbed, more and more workers were getting sick, like really, really sick. Some of them paralyzed, some of them even died. And nobody knew why. Now we do know why. It's something called the bends, which is something that afflicts scuba divers if they come up to the surface too quickly. It's basically if you don't acclimate, and oxygen forms in the bloodstream. And this can be something that paralyzes people and even can kill them. So that's what was happening to the workers, and they called it caisson disease. Gradually, just through trial and error, they realized that they just needed to do it a little bit slower and let people acclimate as they went in and out of the caisson, so that they weren't going from one air pressure to something that was radically different and then back again. But before they figured that out, unfortunately, Washington Roebling, who was on the site all the time and going down in the caisson to check things out, he develops caisson disease and he's incapacitated. He's partially paralyzed and can't be on the site anymore. So 2 Roeblings down, John Roebling and now Washington Roebling. He lived in a house on Columbia Street, I think, in Brooklyn Heights. that had a majestic view of the skyline and of the bridge site. And we'll talk about Brooklyn Heights in a future lecture. So he was able to, you can see here he's partially paralyzed, but he has binoculars so he can check out the work from his window. But that's the extent of his capabilities at that point. So into the breach comes Emily Roebling, Washington Roebling's wife. And she steps in, even though she wasn't trained as an engineer, she had picked up a lot of information from her father-in-law and from her husband about the bridge, because of course it was their entire livelihood, right? And I'm sure it was all they ever talked about. So even though she wasn't formally trained as an engineer, she was in practice, she knew almost as much about the bridge as her husband and father-in-law had. So somebody had to be in charge. So Emily Roebling starts initially like just taking messages to the foremen on the construction site. She's spending more and more time on the site and doing more and more. She's given more and more responsibilities, or she takes more and more responsibilities because somebody has to do it. And she basically becomes the project manager of the bridge and sees it to completion. So, we've hardly seen any women in this course, right? In any kind of position of power. We talked about the commissioner's plan as being, the common council was all men, the governor was a man, the mayor was a man, the 3 commissioners and all the surveyors were all men. They talked about New York as being, the quote better than I do at this point, designed as for the habitations of men. And I asked you on the midterm, would the commissioner's plan have been any different had a woman been involved? The only other time I think we've mentioned a woman, even as a designer, was Susan Delafield Parrish, who was one of the entries in the Central Park competition. But at this point, women were not trained as architects. They were not trained as engineers. And generally speaking, they were not in positions of power. So pretty extraordinary here that, mid 19th century on this gigantic, crucially important project, Emily Roebling becomes the person in charge of the bridge construction. So she was, doesn't do her justice really to say that she was ahead of her time. She was light years ahead of her time. And she must have been incredibly brave to wade into the sea of men every single day and tell them what needed to be done. And to be confident enough that she knew her stuff and she knew about the bridge as well as anybody. It just blows me away. So she starts in 1870, so really pretty early on in the construction process, and is the person unofficially, of course, who sees the project through to its completion in 1883. There is a plaque to her on the bridge. If you walk across the bridge, she is listed as one of the engineers, along with her husband and father-in-law. So the bridge opens in 1883, and suddenly, for the first time, people can get to and from Brooklyn and Manhattan without taking a boat across the river. They don't have to wait for a ferry. The ferry services were always getting shut down in bad weather. Each ferry could only fit a certain number of people, so they were limited in their capacity. During really bad winters in the 19th century, the East River would freeze over. That hasn't happened in a generation or two, but that used to happen fairly regularly. So when the river was frozen, the ferries couldn't run, although you could walk over the ice. But a bridge was just able to handle a much greater capacity of people commuting back and forth. And so what this did was it had a profound effect on the development of Brooklyn, as we'll see, an immediate effect. and Brooklyn then becomes, from the 1880s on, then kind of enters its golden era and becomes a city in its own right. Not just any city, a big city, you know, and a city of neighborhoods, as we'll see later on, a city with its own identity, a city of, you know, egg creams and cheesecake and the Brooklyn Dodgers and all that stuff. That kind of legendary Brooklyn cityscape never would have happened without the Brooklyn Bridge. There was the Brooklyn Bridge, and then there was the Manhattan Bridge practically next to it that was finished in, I think, 1903 or 05. So that certainly helped. And then shortly after that, the subway was extended to Brooklyn, and that had the most profound effect of all. Once the subway was going to Brooklyn, then the population really took off. But the first big step in Brooklyn's evolution was the Brooklyn Bridge, no doubt. Initially, there were trains that went back and forth on the bridge. They're not there anymore. They were taken out during World War II and never replaced. But yeah, initially it was Roebling's idea that there would be trains going back and forth. And here you can see, this is looking towards Manhattan from the Manhattan Tower, looking down at the train terminal. And this is another view from City Hall Park, looking, there's City Hall right in the middle there, and on the right is the train depot. So the Brooklyn Bridge, the trains came right into City Hall Park. So right in the center of the Civic Center, where all the courthouse buildings were, in the financial district where all the offices were. Wall Street is a short block, a few blocks to the south. So right in the thick of the action. And it's not there anymore, but today still the Brooklyn Bridge, all the cars and everything come out right there. So it's, you know, it's a nice looking structure. In the background there, you can see over here, right here is the municipal building by the firm of McKim, Mead and White. And here you can see that it's steel construction, which we'll talk about when we talk about skyscrapers. And then here's City Hall over here, which you know all about, John McComb and Mangan. So here's the railroad going, one went this way and one went that way, back and forth. And then you can see these people here are walking across the bridge. So Roebling wanted to, the original Roebling, John Roebling, wanted the bridge to be something that conveyed people and products across in a really efficient, fast manner. So it was all about getting back and forth, but that was only half of it in his mind, because his philosophy was that he also wanted it to be a place, that the bridge wasn't just a link. It wasn't just a way of getting back and forth. It was a place in and of its own right. So he wanted it to be a place where people will go. So a public space, you know. So Central Park is being built at this point. It opens in 1876. The Brooklyn Bridge opens in 1883. At that point, though, there was still kind of a dearth of spaces in the city where people could go to just relax and get fresh air and things like that. So Roebling wanted this promenade, as he called it, in the middle of the bridge. And it's still there today. And if you haven't walked across the bridge, you really owe it to yourself that you should do this as soon as you possibly can. It's really an extraordinary experience. It's really high. You're really high above the river. The views are incredible of the city and of the harbor. And when this class met in person, I would always take everybody on a hike across the Brooklyn Bridge, but unfortunately we can't do that this year. But you're right up in there in the suspenders and in the stays, and it's really an incredible experience. So whenever you can do it, you should do it. Okay, that's all I have for you today. I can take some questions, and then I'm going to meet with group 1 at 1:30, group 2 at 2 o'clock. Anybody have any questions? I should check out.
Yes, please. I wanted to ask, so after the bridge, Brooklyn started extending. What about Manhattan? Did that help Manhattan anything?
Well, one of the interesting things is that it was a Brooklyn project. It was conceived of by the City Council of Brooklyn and investors in Brooklyn, and they were the ones who got the funding in place. So even though it connects to Manhattan and Brooklyn equally, it really is a Brooklyn project. It's really about going from Brooklyn to Manhattan and then back and forth. It was built to promote and develop Brooklyn. It did have an impact on Manhattan too, of course, but not as much as on Brooklyn.
That makes sense. Thank you.
You're welcome.
Why were trains removed during World War II?
I wish I knew that answer. I don't know. I'm not sure. Doesn't really make any sense.
Yeah, I'll probably look into that later because that would be cool if we had trains going to this day.
Yeah, I mean, there are trains going across the Manhattan Bridge. Maybe they felt that that was enough and they didn't need them across the Brooklyn Bridge. Maybe there was a structural issue that I know on the Manhattan Bridge, the trains do exert a lot of structure, especially because it's an asymmetrical force. There's like one train going this way on this side and then another one. Sometimes there are two at the same time. And it really shakes the bridge. So I know that they've had some concerns about the Manhattan Bridge. They may have had concerns about the Brooklyn Bridge. I don't know. I would love to know the answer if you find that.
Okay, thank you.
Thank you. Noor asks if I was able to play Assassin's Creed 3. I have not had the chance yet, but you know, maybe over spring break, I'll give it a try. Do you just like walk around and look at stuff, or is somebody shooting at me? I just want to know before I play it.
No, it's like I still have like a copy of it, but like it's like this old Native American, like the character's like Native American, and then there's this like Brotherhood of Assassins, and he has to like take out these other like organizations and stuff like that.
I can tell that I'm not going to be very good at that, but I will give it a try.
Yeah.
And if I remember correctly, you start off in Boston and it takes a bit to get to New York City.
Yeah.
You're all experts in Assassin's Creed. That's great. Abram, you asked a very short question, which might need to be fleshed out a little bit. Robert,
I was-
question mark. Is that Robert Moses? Are you asking if he played Assassin's Creed, or are you asking about something else? Are you there? Oh, no problem. Well, you can get back to me with the Robert Moses question. Maybe you're blaming him for taking the trains out of the bridge, maybe? Anyway, I'm always ready to talk about Moses. If there was any effort to fix the posts, what does that mean? Oh dear. Sorry, Abram. I know you're trying to communicate, but I'm not quite understanding what you're. I'm going to move on to Ashley's question. Is there a second lecture? You mean like a second part to this lecture? No, there's not. I got done with everything I wanted to say. Abram, we can talk, later or whatever.
I wish my mic worked.
I know it does work.
Really? You can hear me?
I can.
Oh man, I'm sorry about that. Yeah, I was the Moses thing was about the trolleys because I know that Moses like loved cars and but maybe the structural thing is also the case. But I was really wondering, is there any effort to like extend the Manhattan side post down into the bedrock, because that seems like a structural problem,
Apparently it wasn't a structural problem. I think they cover this in chapter 9, but I'm not positive. Might be in another chapter, but even though it's just sand, it's compacted sand to the point where it's almost like the consistency of concrete. So they literally could not cut through it. So it basically is a foundation, even though it's not bedrock. So structurally, it's not a problem.
That's pretty cool. Ironically, there's a building a couple blocks away from the Brooklyn Bridge that uses like a method of compacting the dirt for a foundation. And apparently the top of the building was swaying several feet, so they had to stop construction. So there's just this like huge steel skeleton of a building right next to the Brooklyn Bridge right now.
Oh, I know the building. I was wondering why they stopped construction. I've noticed that. Wow. Okay. Well, I'll be careful when I walk by. I don't want it to fall on me.
Yeah.
So Yulia asks, why did Roebling get the project? Why was there no design competition like there was for Central Park? Well, you'll see in chapter 1 that it was the Brooklyn government. Also, Boss Tweed was involved on the Manhattan side. And it was one of these decisions that's made in like a smoke-filled room, with like guys with cigars. It just wasn't an open decision. So the fact that they had an open design competition for Central Park was kind of forward thinking, and I think reflects a lot on the kind of idealism of Andrew Haswell Green and some of the people who were on the Central Park Commission. Whereas the Bridge Commission was a little shadier politically, so that's why. Also, there were very, very few people who could have done this project at that point. Just technologically, Roebling was the guy. So. Any other questions?
Professor,
Go ahead, Anderson.
in the caissons, if I'm not saying it correctly,
That's
did
right.
they pump air into the bottom part where the workers worked?
Yeah.
Oh, okay.
They had to, otherwise they would suffocate. Yep. Adina asks a really good question. Who was living in Brooklyn before the bridge? Well, so Brooklyn had been developing gradually in fits and starts. And so in 1814, when they started regular steamboat service back and forth, and that was enough. It was a new enough technology that created a kind of land rush in Brooklyn. That's what led to the development of Brooklyn Heights as like one of the city's first suburbs, because they could take the steam ferry back and forth. So there were kind of, it was a landscape of around the ferry. It was a city, it was Brooklyn Heights. It was like an urban neighborhood. But then further out, there were villages, which we'll talk about in the next lecture, like Flatbush was a village and Bedford was a village. Red Hook was a village. So it was like a landscape like Manhattan before the Commissioner's Plan. So disconnected villages and a lot of farmland. And that persisted all the way, Brooklyn is a huge place. So gradually it became a city, but not really fully until after the subway in the early 20th century. Okay, if there are no other questions, I'm gonna let you go and I will see group 1 at 1:30. Everybody's got the Dropbox link, is that right? I'll send out an email with the Dropbox link just to make sure everybody has that. Okay, I'm gonna look into Blackboard and see what's going on. Until you hear from me, please don't email me your reading reports, okay? So I'll look into Blackboard, see what's going on, then I'll send you an email about what I know. And if you haven't been able to turn in your reading report, I'll come up with an alternate strategy rather than emailing it to me.
I'm sorry, Professor, just a quick question.
Go ahead.
So as I know so far, there is a competition proposal regarding the expansion of the sidewalk of the Brooklyn Bridge that was like a year ago there was. And would you know if the steel grid where the cars are going under is strong enough to expand the sidewalk? Do you know anything about that?
Yeah, it would definitely be strong. If you walk across the promenade that's there now, on either side, you can look down at the roadway, at the cars going by. And the bridge, the Brooklyn Bridge is so overstructured. I mean, you could take out half of that steel and it would still be a really strong bridge. So it would have no problem accepting more promenade, you know, no problem.
Okay, great.
Yeah. I mean, they could put the trains back and the trains would probably, it would be fine. I mean, it's a really strong bridge.
Thank you.
Welcome.
If I could ask about the anchorages, I've noticed like over the past few years on the Manhattan side, they started sort of like clearing them out. They used to be like very boarded up.
Yeah, and I noticed that too. And I was wondering what's going on there.
Yeah, I was gonna ask if you have any clue, but I guess not.
No, maybe you could research that. You know, every time I drive onto the bridge, I notice that and I think, oh, I'm gonna look it up when I get home and see what's going on. I have no idea. But yeah, I have noticed that. It used to be all bricked up and now it's been like opened up, and I wonder if they're gonna do something with it. I don't know. It'd be great if they would let people back in because it's just so cool in there. It's one of my favorite spaces. All right, any other questions?
Professor, is there a part 2 to today's lecture?
No, this is it.
Okay, thanks.
And I recorded this, so I'll put that up on Dropbox and YouTube as soon as I can. Okay, guys, thanks a lot. I'll see group 1 at 1:30.
Brent, should I stick around till everybody leaves to talk to you?
Can you come after the 2 meetings I'm about to have?
Yeah, sure. Should I join the second
Yeah,
link?
join the second one at like 2:15 or something.
Okay, perfect. Thank you.
Okay, see ya.